I'm Doug Fern, and this is my take on music recording. In the beginning, music recording was a totally mechanical process. The sound itself provided all the energy needed to convert audio into mechanical motion to engrave a facsimile of the music onto a cylinder or a disc. And then the vacuum tube was invented. Thomas Edison, who is credited with the first practical invention for recording sound, almost invented the vacuum tube in 1883. I suppose he got distracted by all the other amazing things he was working on, and the tube discovery was left to others. The concept of the vacuum tube went back to a time even before Edison's interest, but it took some accidental discoveries to prompt researchers to develop the triode tube, which was the first device on Earth that could actually amplify a varying electrical signal. That was in 1914. This was only used for radio communications at the time, and not really practical for studio or consumer use until around 1920. Those first tubes were handmade and very inconsistent. However, they did work. A small signal fed into the grid of a triode vacuum tube, say from a microphone, could control a much larger voltage. This more intense version of the microphone signal could be used to drive a loudspeaker for a PA system or to generate a radio signal for broadcasting. By the end of the 1920s, the vacuum tube replaced the sound-driven disc recording system. In those early days, there were only a few tube types. Some were designed solely for converting AC power into DC power. Others generated the radio frequencies needed for communications or broadcasting. All the amplifier tubes were triodes, tubes with three elements: a filament to produce electrons, a plate to collect them, and a grid in between to control the electron flow. It acted like a valve, hence the British term for a vacuum tube. By 1930, tubes started to become more specialized. Some were designed for amplifying radio frequencies in radio receivers. Others were for amplifying a microphone output. And really big ones were designed to produce kilowatts of RF for radio. Radio broadcasting was the amazing technology of the 1920s. Now people at home could tune in a radio broadcast and be informed or entertained. People tuned across the radio dial and encountered radio stations near and far, loud and faint, producing correspondingly loud and soft music or voices. For experimenters, this was a minor problem. They just turned the volume control up or down to compensate. But for people who just wanted some entertainment or the latest news, the variation in volume from station to station was very annoying. The answer was a specialized variation of a vacuum tube that could be set up to automatically level out the differences in volume. Radio receivers that had this feature called it automatic volume control. The same tube could also be used to prevent overmodulation of a radio broadcast transmitter or to limit the amount of needle excursion in a disc cutting lathe. Engineers also quickly realized that this tube could also increase the apparent loudness on a record or over the radio. This was the start of the never-ending quest for greater loudness. Although many other approaches to automatically controlling levels have been developed over the decades, the system that uses a vacuum tube control element has persisted as a unique sound. The specialized tubes to vary the gain of a signal have been miniaturized, but they all share the same ancient DNA. Scientists measured the characteristics of various configurations of elements within the tube and developed mathematical formulas that described how a tube worked. From there, it was easier to design tubes for special purposes. Dozens of new tube designs resulted, and they continued to be refined. Designers realized they could fit two independent vacuum tubes into one glass envelope. That saved some space, but the tubes were still big. By the mid-1930s, the ancestors of most of the tubes we enjoy using today were already developed. They were big and used large sockets. They used a lot of power to perform their function, but no one seemed to mind too much. Just a handful of tube types were used in many different applications. They may not have been perfect for a particular use, but they worked fairly well. World War II really accelerated the need for smaller tubes for military use. Instead of starting from scratch for many tubes, engineers simply copied the specifications of the big tubes and scaled them down to what were called miniature tubes. Those miniature tubes are what we are most familiar with today, at least for studio gear. The science of making tubes accelerated rapidly during the war, with a need for special purpose devices for radar and other military equipment. Miniaturization was vital for use in applications where size and weight mattered, such as in airplanes, or with radio transmitters and receivers that could be carried by a soldier on the battlefield. Also during this period, electronic computers were invented in England and in the U.S., mostly to help break the coded messages of an enemy. Those used vacuum tubes, lots of them. The computers were huge. They did the job, but the computing power was but a fraction of even the simplest digital device today. Computers could go no further with vacuum tubes. Vacuum tube computers were just too big, complex, and hot for all but the simplest tasks. Bell Labs, which invented just about everything in audio and electronics in the 20th century, developed the transistor in the late 1940s. They wanted a simple switching device for use in the telephone system. Plus, they saw how a tiny device could bring the size of a computer down dramatically. Early transistors were not designed to be linear devices. They only needed to be on or off, not like the continuously varying analog world we live in. They did that switching job great and continue to do so today. Transistors were primarily digital devices with just two states, either on or off, not much in between. You could not put audio through them and expect even a faint replica of what went in. But everyone wanted to get rid of vacuum tubes. The transistor was envisioned as the future of all electronic devices. With transistors, every electronic device could be made smaller, lighter, less energy intensive, and produce less heat. The term solid state was invented to differentiate the transistor, which was fabricated out of a piece of silicon, from vacuum tubes, which worked on an entirely different principle. Early attempts to use transistors to amplify audio did not sound good. Some of us would say they still do not sound great. However, with a lot of effort, transistors eventually sounded pretty decent. But for many of us, they never sound as good as vacuum tubes, which are true analog devices. Tubes have their deficiencies for sure, but the characteristics of the vacuum tube seem to match the analog nature of musical instruments and our hearing in a uniquely pleasing way. By the 1960s, manufacturers were trying to adapt transistors for recording. The early products had a lot of distortion, but they did improve with time. Still, vacuum tubes remained the best way to amplify and control audio. But by 1970, no one wanted tube audio gear. Tube condenser microphones were redesigned to use transistors. Instead of a separate power supply, condenser mics could now be powered through the mic cable. Mixing consoles of the tube era had much of the active electronics in separate racks, not inside the console. The number of inputs and outputs was limited because the electronics were big. Transistors were the answer. To further miniaturize electronics, designers figured out how to put more than one transistor on a small piece of silicon, and the integrated circuit was born. Early ICs had only a few transistors. Modern ones have thousands. Now, most audio is amplified through specialized integrated circuits called op-amps. The small size of transistors and op-amps made the modern mixing console possible. By the way, the op-amp, short for operational amplifier, was first invented using vacuum tubes. This circuit was used in analog computers, which performed operations on any random voltage and could provide a mathematical analog of the process. The op-amp could add, subtract, multiply, divide, or compare the voltages, a useful process for certain types of information processing. The original op-amp was not designed to amplify audio. However, the solid-state version eventually did that very well and still forms the basis of most of our solid-state analog gear, like consoles. To show how rapidly tubes were eclipsed, I took a look at a book on my library shelf. It is a catalog from a supplier of electronics parts from 1967. It lists about 1,300 different tube types. And that does not include special-purpose tubes, such as cathode ray tubes used in television sets, or big industrial tubes used in transmitters, X-ray machines, and other specialized applications. A designer of that era could find a tube to do just about anything they wanted. Despite the rapid adoption of transistorized audio electronics, some people continued to prefer the sound of vacuum tubes. But it was largely a lost cause. Except for a few manufacturers that stuck with tubes, it was a solid-state world by 1980. I think audio quality suffered because of it. Sure, ICs made possible multi-track tape machines and gigantic consoles, but did we lose something in the process? Was it worth it? What happens when the solid-state sound becomes the accepted sound of music? Now, over 40 years after tube audio gear became relegated to a vintage category, have we lost sight of what music really sounds like? It's a trade-off, and we have to weigh whether it is worth the downsides of both tube and solid-state technology. Ironically, the transistor was almost invented before the vacuum tube. Scientists experimenting with semiconductor materials like germanium and even lead stumbled across some interesting properties of those materials that would eventually lead to the transistor. But the technology to fabricate such minute devices was lacking, and the research was abandoned when the vacuum tube appeared to do exactly what was needed. By the way, the LED was discovered around the same time, but it took many decades before it was developed into the devices we use today. But what if the transistor had reached refinement before the vacuum tube was developed? We might never have known the sound of tubes. But back to our story. Obviously, no one after 1970 was developing new tubes. Tubes became a minuscule market, mostly just for maintaining old gear that sounded great and was still in use in recording studios and in guitar amps, and also by some audiophiles who preferred the tube sound. Up until that point, giant manufacturers like GE, RCA, Sylvania, Philips, and many others cranked out tubes by the millions every year. But the demand diminished to the point where it was no longer profitable to make tubes for an ever smaller market. New tube development stopped too. Near the end of tube production, huge quantities of surplus tubes ended up in warehouses or in landfills. Some small percentage of those tubes can still be found. In other parts of the world, particularly Russia and Eastern European countries, the tube factories continued to make tubes. Some are still in operation today. The tubes for the D.W. Fern and Hazelrig Industries products come from these Eastern European factories. The world has exhausted new old stock supply for all practical purposes. The current production tubes we use are just as good as those made by the big U.S. manufacturers, so we are able to continue building our products and maintain the quality. How long will these companies continue to make tubes for a minuscule market? No one knows, but it is likely that at some point it will no longer be economical to keep those factories going. Plus, the expertise for making tubes diminishes as each generation of skilled factory workers is replaced by a new one. But we believe we can supply our products for a long time. We stockpile years of tubes, not only for new products, but to support those that are out there now. I designed the D.W. Fern products for a minimum of 50-year lifetime. Actually, I expect them to last longer than that. We should have enough tubes to continue manufacturing for decades, and enough to supply replacements when necessary. But here is the tragedy. The sudden abandonment of tube technology in the 1960s stopped all further progress. Up until then, scientists continued to refine the potential for vacuum tube design. Smaller tubes, tubes with several individual tubes inside, lower noise, lower distortion were in the works when the plug was pulled on all future development. But what if that didn't happen? Suppose the recording industry had enough clout that it could insist on the continued development of tube technology. Where would we be today? I can only speculate, but based on the advances in the 1960s and early 1970s, we might be astounded by a tube of the 21st century. Tubes would continue to shrink. Perhaps they would be etched out of silicon like modern solid-state devices. There was some experimentation in that era a decade or more ago, but a silicon-based tube was never developed as a product. Not only would this device be much smaller, but it would use far less electricity to do its job and hence generate less heat. It might have other highly desirable characteristics if designed specifically for audio use. It is conceivable that tubes might have shrunk to the size that made a vacuum tube console a practical reality. The performance problems with all amplifying devices, tube or solid state, are things we fight with all the time in the studio. Noise, distortion, frequency response, and reliability mainly. Back in the days when recording was captured on magnetic tape, there wasn't much incentive to make tubes quieter, have lower distortion, or extend a frequency response because of the limitations of the tape medium. Tape is noisy and quite nonlinear, which introduces all kinds of distortion. The electronics did not have to be particularly great because the tube deficiencies would be overwhelmed by the intrinsic problems of tape. I love the sound of tape, but it was a constant battle to use it effectively in the studio. Even using tubes designed in the 1950s, I and others have designed products for recording that work just fine with the improved performance we enjoy with a modern digital recorder. It just takes a bit of work and expense to design a tube audio product that meets the low noise, low distortion requirements of digital recording. But if vacuum tubes had continued to evolve, we might be looking at our digital recorders as being the weak link in the recording process, just like tape was in the past. What about going to a new generation of tiny vacuum tubes for digital devices? That's not really necessary, since the simple on-off nature of digital is handled quite well with transistors. There would be no advantage to using tubes there. The exception would be in the analog sections of a converter. There, a tube front end or output stage would offer sonic advantages. You use the best technology for the job. The research and development cost to invent a new generation of vacuum tube technology is far too great for anyone to undertake. The market is way too small to support that kind of investment. It appears that we are stuck with what we have, a technology frozen in time. It could have been very different, but unless we can access a parallel universe where tubes continue to be valued for their amazing sonic qualities, I'm afraid the day will come when the beautiful sound many of us cherish will come to an end. My goal, and those of a few other manufacturers, is to keep the sound of vacuum tubes alive for music as long as possible. That could be for quite some time. For more on vacuum tubes, you can take a listen to a couple of previous episodes of this podcast. There is one called Vacuum Tube Fundamentals from May 2021, and another, Vacuum Tubes, Why They Sound Better for Audio, from July 2020. I appreciate your comments, suggestions, and questions. Reach me at dwfern@dwfern.com. And please share this podcast with others you think would enjoy it. Thanks. This is my take on music recording. I'm Doug Fern. See you next time.